In this first example, you're being asked to express 81 as a power of 3. And you can see that what that means is 3 to what power equals 81. Well, you can figure that out by just multiplying 3 times 3 to get 9 times 3 to get 27 times 3 to get 81. And you'll see that's 4 3's we multiplied, therefore 3 to the fourth is 81. For the next problem, we're trying to figure out which is greater. So look at that problem for a second, and you can probably figure it out just by looking at it. We're going to go ahead and simplify it. To be sure, we end up with 12 squared on the left, 12 times 2 on the right. So that's 144, which is clearly greater than 24. In the next problem, we're being asked to write each of these as a single power of the given base. So that's different than simplifying. Simplifying, you'd get a final answer. Here we're just going to write the base down and figure out what the final exponent should be when we put all the bases together. So in the first one, we know that 4 squared is 4 times 4, 4 cubed is 4 times 4 times 4. So that's 4 to the fifth altogether because we're multiplying 5 4s. Next, try that one. We end up with 7 5s and another 3 5s, so altogether we're multiplying 10 5s, or 5 to the 10th power. Try the last two and then check back here. So you should end up with 9 to the 4th for the next one. I'm sorry, there was only one. All right, let's keep going. Now, in the next examples, we're asked to evaluate algebraic expressions. These are expressions because they do not have equal signs, and because they have variables, they're called algebraic. So they're algebraic expressions. And evaluating means we're going to substitute the numbers for the variables that they represent. Now, this next little tip is really important. When you substitute a number for a variable raised to an exponent, the number, including its sign, belongs in parentheses. So let's see how this plays out. I'll just go through the first example with you. So in this first example, we're going to see that we have mn squared, where m is -2 and n is -4. So I'm going to substitute -2 in the place of m and -4 in the place of n. Now here, the negative and the 4 are both in, so we have to include the negative and the 4 in parentheses when we're raising it to the second power. In other words, we're squaring -4. We're not just squaring 4. And that may seem simple, but we'll talk about that in more detail. So when we simplify, we need to choose between multiplying or exponents, and we're going to do our exponent first by order of operations. So we end up with -4 squared, which is 16. And -2 times 16 is -32. Pretty simple, right? Well, I want to show you that that's actually different than if we had written it with this notation over here. -2 times -4 squared with no parentheses. So if you don't have parentheses, like in this example, then all you're squaring is the 4, not the negative. So you get a different answer. You get -16 instead of +16. And then your final answer is +32 instead of -32. So let's think about this a little bit more. So over to the side here, I have some notes to help you think about how all this works. So in this first example, -5 is within the parentheses. And in the second example, -5 is not inside the parentheses. Now, the way that exponents work is they only get applied to whatever they're next to. So with parentheses, the 2 exponent is being applied to the parentheses, to everything within the parentheses. Without the parentheses, the exponent 2, is being applied only to the 5, not to the negative. So you'll see in this first example where the 2 is outside parentheses, we actually square the negatives and the 5s, and that's why we end up with -5 times -5 equaling 25. In the other example, we only square the 5s, and we just bring the negative down. so we end up with negative 25. Another way to think about this is with the example with parentheses. That actually means negative 5 squared, just like you probably thought. In the example without parentheses, that actually means 5 squared, and then find the opposite of it, which would be negative 25. So having parentheses is a really relevant piece of information. And when you're doing a substitution problem, you're being told that the variable n is negative 4. So when you substitute negative 4 in the place of n, and you know that that n is being squared, you know that negative 4 is being squared. Not just the 4, but the negative 2, because n is negative 4. So try the next two problems and then come back and see how you did. So in this next problem, you should have substituted negative 2 in the place of m, negative 4 in the place of n. You don't want to change these two negatives here to a positive because you have to deal with the exponents first by order of operations. Negative 2 squared is 4. Negative 4 cubed is negative 64, because that actually equals negative 4 times negative 4 times negative 4. And we know that 3 negatives equals a positive. Equals a negative. So if you have an odd number of negatives and you're multiplying or dividing, you'll end up with a negative. So now we have 4 minus negative 64. So now we can go ahead and change this to addition. And 4 plus 64 equals 68. Let's look at this last problem on this page. And this one's pretty tricky. So this negative 3 squared, that negative 3 is not in parentheses. So you should end up with negative 9. First, however, you want to do your substitution step. So now I end up with negative 9 for negative 3 squared minus negative 2 to the 4th is positive 16. So now I'm going to change this to addition. Negative 9 plus negative 16. All that's in parentheses raised to the 3rd power, but we need to simplify our parentheses before applying the exponent. So we end up with negative 25 cubed, which is negative 15,625. So let's move on to the next page. On the next page, we're going to move into comparing adding like terms. Actually, let's go ahead and stop at this point.